Hi guys, I want to talk briefly about something that's kind of the basis for two-dimensional motion. That is being able to use vectors to represent motion in different ways. We've been talking vector quantities already, and a vector quantity is something that has both a magnitude, a numerical measured amount, and a direction. So displacement, velocity, acceleration are all vector quantities. We'll use force later in the trimester, and that's one that we use a lot. But we're going to focus primarily on velocity as a vector, but we can use that in a lot of different ways as well. So one of the concepts that I want to talk about is what happens when we have two dimensions in terms of vectors. So I have this situation here that is a boat moving across a river. So we know the boat can travel 10 meters per second. That's the velocity that the motor can push it on at, and the current pushes it at 5 meters per second. All right, so those are our vectors here. Now, in class, we discussed how we would answer these four questions here. What direction should the boat be aimed to get across the river the quickest, to have the highest speed, have the lowest speed, and get directly across the river? That's four different questions, and we need to answer those. Now, the easiest ones are the highest speed and lowest speed relative to a person on the shore. If they're looking at the boat when it's going the fastest, it would be going parallel to the river in the direction of the current. So its total velocity would be 15 meters per second. So we would have the 5 meter per second vector of the current and the 10 meter per second vector of the boat motor for a total of 15 meters per second. Whenever we add vectors together, they have to be the same type of vector, and they have to add tail to tip. So we can take them, and it doesn't matter what order I put them. If I put this blue one behind the green one, they'd still add up to 15, and that would be appropriate. Now, if the boat is going against the current, then we would have the boat going in this direction, and the current going in this direction. So tip to tail, it'll go like that. And we'd have a resultant vector. A resultant is a sum of multiple vectors. The resultant would be 5 meters per second. So the boat would be traveling 5 meters per second in the direction of the engine. So here's our resultant vector, the red one here, of the boat going with the current. So that would be 15 meters per second. Here's our resultant vector of the boat going against the current when we add the two together, and that would be 5 meters per second. There tends to be some error in understanding what happens to get across the river the quickest. And actually, I drew the vectors that would get across the river the quickest. And that is this situation down here from the boat. To get across the river the quickest, you want the boat to aim directly perpendicular to the current. Now, the boat's not going to travel directly across the river, and it's not going to be going at 10 meters per second or at 5 meters per second. It's a combination of the two vectors, but the key here is that they're perpendicular. And perpendicular vectors are independent, which means they don't affect each other. The most common error that people say to get across the river the quickest is to aim the boat somewhere like this. But that won't work, all right? And the reason that won't work is because the current then affects how fast the boat is going across the river as well. So this perpendicular arrangement actually allows the boat to continue traveling at 10 meters per second across the current, even while the current's pushing it. If you're going at any angle to the current other than perpendicular, the current affects the speed across the river. So you're going to have a slower time to get across the river. Now, we can solve the actual speed by taking the Pythagorean theorem and taking 10 squared plus 5 squared, so 125, and taking the square root of that. And the square root of 125 is 11.2 2. So the boat would actually be traveling 11.2 meters per second. And we would also need to take an angle, either that angle or that angle. And when we do that, I'm going to do inverse tangent. And whenever we do angles in physics, we do them with degrees. So you have to be in degree mode. So inverse tangent of 5 over 10. And that is 26.6 degrees from across the current. In one-dimensional motion, we can use positive and negative. In two-dimensional motion, we have to use angles and refer to what that angle is measured from. So you could say 26.6 degrees from directly across the current. You could also take that and subtract it from 90 degrees and use 63.4 degrees from the shoreline if you wanted to. So the boat itself is actually traveling 11.2 meters per second, but the motor is pushing it 10 meters per second. The current is pushing it 5 meters per second perpendicular to that. If the river is 1,000 meters wide, it's going to take 100 seconds to get across. So that means the boat will land 500 meters downriver from where it started and 1,000 meters across from where it started. To get directly across the river, one would have to aim the boat slightly against the current, enough so that the current would bring it back to directly across the river. But notice the component of velocity, and components are the parts, the vectors that add together. The component of velocity that moves across the river then is less than the 10 meters per second. So it's not going to get across the river as fast. It also has a farther way to go. Or it has a shorter way to go, I should say. If it aims downriver, it has a farther way to go, and that farther way to go to get across the river overcomes the fact that the boat is moving faster. So the key here is that we have perpendicular vectors that are independent. As we start talking about projectiles and things moving through the air, we're going to talk about horizontal motion and vertical motion, because horizontal motion and vertical motion are perpendicular to each other. The things that affect the horizontal motion versus the things that affect the vertical motion don't affect the other. And that primarily is gravity. So gravity affects vertical motion, but it doesn't affect horizontal motion. So that's what we'll talk about next. Thanks.